Hello everyone, welcome to the third part of episode 4. So we've already taken care of dialogue segmentation, which was great, and we've just taken care of our speaker data casting. Not doing much for us right now, but it will in the future, I assure you that. And there's only one more thing that we need to take care of to complete our dialogue parsing, and that is to take care of all the commands at the end of that dialogue line. So how this system works is we have our speaker, we've got our dialogue, and at the very right hand of the line we've got all of our commands. That's where they're going to go. Or we could just omit the dialogue and we could straight up have just regular old command lines and just have nothing but commands to execute at a certain point in the file. That's totally possible. But the way this works is you specify the name of the command, and this name is going to be sent to a command system, which will then look in its database, find the appropriate command, and then execute whatever logic is supposed to run when that command is called. That logic will run, taking in the arguments that we provide, basically exactly how we call scripts. It's what we've been doing this whole time, only we're going to integrate it into a text file now. So we'll be able to call commands that we create in script straight from our text files. And setting it up is not that difficult either. There's a couple intricacies to it, especially when we actually get into the management system, but as far as parsing goes, it's going to be very simple. We're only looking for a name, and we're looking for the parentheses, which identifies the start or the container for our arguments, and that will get us everything we need for the commands. We separate commands with a comma, and maybe we'll have space in there, and then we just precede it by any additional commands that we want, going on for as many commands as we want. We're going to head into our data containers, and we're going to make one more script here, and this will be for our command data. So we'll make dl command data. Once it's compiled, let's open that bad boy up. Okay, wow, that looks like some jitterbug there. Let's scroll out. I don't need it that big. About 99% is comfortable for me. So you know the drill. Let's get rid of update and start and remove mono behavior because this is not object bound. Now, command data is going to need to store some data, obviously, which is only going to be a list of our commands. So this struct is going to be called a command. Okay, and in here, we want a name for the command. That's what we're going to send to our database to call it. And then we want an array of arguments. This will be passed in alongside the command to control how it's run and what it does. And so our command data is just going to have a public list of commands. And for our speaker data, we made it where we had these constant fields that we could change out for the different keywords if we wanted to swap those. We're going to do the same thing for commands here, and that's going to be for our command little splitter, the comma that divides the commands from each other, and the container, which is used to hold the arguments, because maybe we'll have those, maybe some people will have those different for some reason. Constant character is going to be for our comma, or our command splitter, and I'm going to call that command splitter underscore ID and set that equal to a comma. Do the same thing for my container ID, and this is, I'm going to call this one arguments container ID, and that one is going to be the starting parentheses. That way we've got it in one place, easy to edit, and we don't have to worry about strings being all over the place again. So now let's make our constructor, public DL command data. Inside of here, we're of course going to take that command line, but I'm going to call this raw commands to keep in league with the other functions for our dialogue and speaker. And we need to populate our commands list. So what we're going to do is we're going to rip all of the commands right out of this line. So let's make another function which is going to return a list of commands. And we'll just call this rip commands, taking in that raw command data. And once we have constructed our data, what we're going to do inside and say that commands equals rip commands, passing in the raw command data that was pulled from the line. Alright, so in case we have more than one command to a line, the first thing we want to do is we want to split them up from each other, and then we can work on each one independently. We can separate them into an array, and just call it, we'll call it data, and I'm going to make this equal to our raw commands dot split by the splitter ID, and I'm also going to specify to remove any empty entries in case I have made a comma but didn't put anything out there by accident. Because you guys know me, if there's one thing that I will do, it is mistype something in a heartbeat. Now let's go ahead and create the return container that's going to store our commands and then give it back in our constructor. So list command, and we'll call this our result and set that equal to a new list of commands. Perfect. And now we just need to go through each command that we separated into our data array. Once we have this, we need a new command to store our data in. So we'll create it saying command equals new command. And now we need to split the name of this command from all the arguments that it contains. And we can do that by referencing our container ID up here. Now, because we're only looking for one, we don't need to go through the complex process of regex. We could simply use the built-in function on a string to find the index, the first index of whatever character we're looking for. There should only be one parentheses in the line, so we can get away with this pretty easy. We can specify an integer for our index and set that equal to our CMD, the string that we're looking at, and pass that into command splitter, well, not the command splitter, but our arguments container ID. So we're going to find the index of that parentheses, and we'll use that to create the substring that will build our name. And we'll set that as command name to equal the substring starting at the very beginning, proceeding as far as that first occurrence. And if there's anything on the end of that, if there's any white space before the command or afterwards, then all we'll do is just trim all of that off. So that way we've purely got the name there, which means our command.arguments now need to be populated with something. And rather than have this whole script or this whole function get overly complicated and a little bigger than it needs to be, we'll separate this into another function. So we'll call a private string array, so that way we get all of our arguments into a single array, and we'll call this getArgs. And what this is going to take is a string representing all the arguments. So that means we need to pass it in here. So our arguments is going to equal getArgs, and then we need to actually get the argument string, which is going to be cmd.substring, and we're going to start at index, remembering that index is actually our parentheses, so +1, that's where we're starting, proceeding all the way to the end at cmd.length, and just subtract it by the index from our starting point, where these arguments occurred at, and additionally subtract 2 from that so we can cancel out the length of the 2 parentheses, or the 2 container characters that are present in the arguments. Okay, that rips it, so now we will officially have any arguments inside of the command getting passed into this function. And when we go to rip these, like I said, here's how the arguments work. I've already said that if we have a command called play song, and it takes a song name as the first parameter, volume 1, tac, pitch, set that to 1, every single one of these is a parameter. Now this is the entire argument line. This is what we've just ripped, and we're now throwing this into get arguments. We've already got our name, so that's out of the way, and we're just finding every single argument in here, with that one thing that is separating them all being the space character. But like I said in a previous video, we're not just splitting by spaces, because we want to encapsulate multi-word arguments into one argument using our quotation marks, which means we want to ignore white space in certain circumstances only if they're surrounded by quotes. Now this is sounding an awful lot like when we were ripping our dialogue lines, like we were wanting to ignore quotes if they were escaped. So just like we're wanting to ignore spaces if they're inside of quotes. We're kind of going to be running the same sort of parsing that we did for dialogue as we are in commands here, only with one bit of difference. With the dialogue, we were looking for the index of the first quote and the index of the last one, and then everything in between was dialogue, and, everything else was discarded. So actually what we're going to be doing here is we're going to read this entire string character by character and just build it. Just build every single argument one character at a time using a string builder and just get all of our characters that way. And once we encounter the space, then we save that argument and we move on to the next one. And we save and we move on to the next and save and move on to the next. And then before you know it, we've got our whole array of independent arguments. So that means our logical first step is we're going to make a list of strings, which is going to be our argument list. And the way we're building this, to be a little faster than concatenation, we'll be using the string builder. And the reason we're using string builder, like I said, it's faster than concatenation, which is where you just add a character or add more strings to a string. When you do that, when you say something like string plus string equals the new string, you're basically creating a brand new string and discarding the other two that you referenced. With string builder, you're not discarding anything, you're just building on what you've already got there. So there's no excess memory wasting there. Even though it's minimal with concatenation, over time it can add up. It's just one of those optimization things. So we're using string builder here for that. And then we also want to know, hey, are we in quotes? If so, we want to ignore any spaces that we find. So let's make ourselves a Boolean called in quotes and set that to false real quick. Great, and now we can iterate through our whole argument string. All right, first thing we want to look for is any quotation marks. So let's check our first character. If args I equals a quotation mark, then we want to go ahead and do something. We want to say in quotes equals true and continue on to the next character. Then we want to see if we've hit a space, but only if we're not in quotes. So if not in quotes and args I equals a space, if we're not in quotes and we found a space, then we know that we've hit the end of whatever argument we were building, and we need to go ahead and save it. So we can say arglist.add, and we're going to add the text that is on our string builder. So we'll reference the string builder and say toString. And now we've saved our argument. And all we need to do is say current arg.clear and continue on to the next character. If we haven't found a space and we haven't found a quote, then we want to append the character that we're on to our string builder so that way we can build our arguments character by character. Okay, and that's good, but that only works until the very last character. Because we could come to the end of our parentheses. If we look back at the test file, we have all of our parameters, so we build it, and then we hit the space, so we save that one, then we build that, we hit another space, we save that, we go all the way to the end, and now we're building this one, but we don't have a space there. And we also don't have that parentheses to look for. So once we've hit the very end and we've exited that loop, we need to make sure that if we have anything else that's in our string builder, we save that as an argument as well. Otherwise, we're going to be missing our last argument in every single run here. So after we exit the loop, we'll say if current arg.length is greater than 0, meaning we have something that we were building before this stopped, then we'll go ahead and say arglist.add with the string builder dot toString and add that last argument. And then we're just going to return the arglist dot toArray. Convert our list to an array and give it back to the rip commands function here. So that gives us our name, that gets us our arguments, and we just need to add this command to our results. And once we're done there, once we exit this, we're done with all of our commands, then we just return the result. And that's it. That's all there is to it. We are ripping our commands, but we need to make sure that this is working, don't we? First thing we need to do is come into our dialog line and replace this string with the new command data that we've made. Alright, and once we try to get that data, we'll say, well, we may not have commands, just like we may not have a speaker, so we need to check that first. Just like we did for our speaker, if string.isNull or white space, we're looking at our commands to see if we've got anything. If it's null or white space, then we don't want to return anything. Otherwise, we want to return a new DL command data and build it from our commands. Wow. Wow. Build it from our commands. There we go. And we will just set this to be true if our commands is not equal to null. And maybe I'm OCD, but this will bother me now, because these two are making that check and this one is not, and I could remove that variable and just set this to a null check as well. So why don't we do that for our dialog as well, because we may not have dialog either. Remember, this could be a command line, just a command line with no speaker, no dialog, which means this could be null too. So let's run that check here as well, which means we'll change this not equal to null, and just come into dialog data and remove that check because we don't need it. Okay, so I'm going to hop back into test dialog files here since we've still got this one active in the scene. And once more, I'll go ahead and comment that out. Maybe I should have stopped deleting those iteration loops here because I am now recreating this for the third time. Alright, going to convert this to a dialog line. DL equals dialog parser dot parse that bad boy, and then I can go through and check the commands. Okay, so I'm again making the line and then iterating through every command in our list, although I noticed that we have our command name here, which is a little strange. So we have dl.commands.commands, not very intuitive, so how about we go back into the dialog line and make a slight change here. So speaker data, I'm not sure how it is for y'all, but in Visual Studio I can control RR and rename this, and it renames the instances across the assembly. So I will make this speaker data instead. I'll change this to dialog data, darda, no, that's data, and then I will change commands to command data, and then come back into test dialog files, and there we go, dl command data.commands.count. That looks a little better to me, a little easier to understand there. So as we open Unity, we have no errors, or we shouldn't anyway, I don't have any. And I've got the test dialog files here, so let's go ahead and start that, after I add some commands in here. Okay. Alright, so you'll see that I've added some lines here in this dialog segmentation text, and each line now has some commands at the end. Some of them have those quotation marks so we can see everything working. So let's look if it's ripping all of this as it should, even the ones that are just on there without any dialogue or anything. So these are just command lines, and then I've got speaker, dialogue, and commands paired together. These are the different kinds of lines we can write, so let's see how Unity handles that. Okay, so as I launch it, I can see everything appears to be working fine. If we look here, we are parsing the line, John, let's play music. The first command is play song. Indeed, command 0 is play song, and it says it has arguments funky beats, tac v, tac 0.75. It doesn't look like it's separating with the comma that I asked for. So in set background, I can see that it is separating with the commas. That's working. And parse line, let's see what this looks like. Set CLI has the arguments. Yep, those are working. But legendary boombox true is not. So it looks like anything that has quotation marks in it is not working. So let's go back and look at that. Once more, I just need to slow down. I gotta remind myself, slow down. I'm letting autocomplete take care of me too much. This needs to be not in quotes. So once we hit quote, we toggle out of our in quotes Boolean. There we go, and there we are. So funky beats, that gets added as one argument because it was in quotes, and then everything else is separated by those commas. Awesome. So all of this does appear to be working just right. Yeah, I might be typing a little too fast and talking a little too fast because I'm trying not to make 50-minute videos, but that's not going too well. Everyone seems to be enjoying it nonetheless, so I'm not going to rush it. I'm just going to make sure that we get where we need to go and that everything's clear along the way. So that is great. We've got our parsing done. That's all we have to do for our command data parsing, and now it's just a matter of sending it to a command system that's going to interpret those commands and then execute whatever logic is assigned to them. And this is where the real power in the system comes. So we come into our scripts, we'll go into core, and it doesn't belong to dialog, it doesn't belong to any of these, so we'll create a new folder, and we'll call this commands. Inside of commands, we're going to make a C# script called the command manager. The command manager is going to handle all requests for commands, and it's going to execute the actions after consulting with the database that it has. So speaking of the database, let's create a new folder called database, and in here let's make ourselves a C# script called command database. And the reason we're putting this in a new folder is because the database is basically going to be a list of commands that can be run. This list of commands, it's going to be a dictionary, and it's going to be a dictionary of a string for the name of the command and the action that's going to be executed. Which means all of the commands that it needs to run, they're going to have to be added to that dictionary by what we'll be calling database extensions. You can create extensions and add your own commands inside of them, and those commands will be added to the database, which the command manager can then access and then run the logic on when it receives a request. So the way we can extend our database is we'll have another base class, which is going to be a CMD, just to keep the name shorter, database extension. Okay, so we have a command database extension. And let's go ahead and open up these scripts. So our conversation manager, these are both managers, but our conversation manager was just created by the dialog system and it's held within memory. Our command manager is going to be a little different. It is going to be a mono behavior, and we are going to tie it to an object in the scene because it's going to need to handle its own commands. It's going to need to handle some commands that run over long periods of time. We'll call those long-running processes. But that means I don't want it to send requests for commands to, like, say, the dialog system or some other object in the scene. I want it to handle everything itself, and that'll truly make it independent. What we can do is remove start and update and make a new void called awake. Inside of awake, we're going to initialize this command manager and make sure it's got everything that it needs. So let's think about who needs access to this. Obviously, our dialog system is going to need access to it because it's going to need to execute commands as it's running these conversations. So in order for it to access that, instead of linking it in the script, we'll go ahead and make a singleton here and give it an instance. So a public static command manager instance, and we'll make it public to retrieve and private to assign. Inside of awake, let's do a check and make sure there's not already one in the scene. There should only be one at any time, but just in case you have one that may persist through scenes, it'd be helpful to check first. So if instance is not equal to null, then instance equals this. Otherwise, if the instance is null, then we want to go ahead and destroy immediate, and we're going to reference the game object on this particular controller. So we don't want any more than one in the scene at any given time. So once we make this command manager, once it awakes and initializes itself in the scene, it needs to go ahead and reach out and update its own database. So the command manager is going to have a reference to a database, and this is going to be a private command database where it's going to store all of those commands. So let's hop into that script real quick. Now this one is not going to be tied to an object, so we can remove all that fancy stuff. And in our command manager, after we assign the instance, we'll go ahead and say that database equals new command database. Let's go ahead and just create a brand new one. So as we have this database here, it needs to keep track, like I said, of all the commands that are available for this system to run. As we're building our visual novel, we're going to have a lot of things like music, character movement, scene transitions, you name it. All these things are going to be executed at different particular points in our scenes, and our scenes will be controlled by these dialog files. So we're going to need to have all of the commands that we plan to use at some point sent to this command database, so that way they can be referenced from whatever is handling those actions. And this is going to be controlled by looking at a dictionary and finding the command and finding the action that's associated to it. This is just going to be a private dictionary because we don't want anything to have direct access to it. We'll do that through a function, and we'll have a string as the key, that's the command name, and then for the action is going to be a delegate. And this is going to be our database. And you see that delegate is underlined here. So if we look here, we just need to use the system namespace. That was one time where Visual Novel did not add it, so I'm actually glad it didn't do that. I got to show you. And we're going to make this equal to a new dictionary with those same variables. And the way that we'll know if we have a command in here is we're going to make a function that returns a boolean that tells us whether we have a command by a particular name or not. We'll have a public boolean returning function called hasCommand, wherein we're going to take a string for the command name. And all this is going to be is one line, so we can point this function to a result of database.containsKey and look for that command name. If we have that populated in the dictionary, this is going to return true, and our system will know that it has that command and it can proceed to execute it. Which begs the question, how do we go about adding commands in here? It's not like we're making a pre-populated list, and nor should we. This should be dynamic and something that you can control externally and through making of additional extension classes. So in our database extension, let's go ahead and remove these two functions and remove mono behavior as well. And we want to convert this class to be abstract, which means that this class in itself can't be used, it can't be instanced. It needs to have something that inherits from it. So we can only use an extension if we create a new script that inherits from this extension class type. And when we have an extension, there's only one thing that it needs to do, and that's extend the database with its own logic. So we are going to have one command inside of here. This will be public, but, and we'll discuss this in a minute, the command needs to be static. Like I said, we're not going to have any kind of instance, so it needs to be able to be accessed from the class type itself. So we make it static, and we'll have a void return type, and we'll call this extend. And what this is going to take is it's going to take a reference to the command database. And that is the class, not the database itself, the class that holds the database. So we'll pass that class in, and it's going to be empty because it's not going to do anything by default. This is abstract, it won't be used by itself, so all the logic for extending will be in the subclasses that we create. So real quick, let's go into Unity and make our first extension class. Let's go ahead and create a new folder in here which will hold all of our extensions, and we'll just call it extensions. And I'm going to make one little script in here. This is not even necessary, but for testing and for ensuring that everything works, and, you know, for examples, I guess you could say it is necessary. This is going to be our CMD database extension, and I'm just going to call it examples. So the first thing that we'll do is we'll remove mono behavior, and we're going to replace this with our CMD database extension class, because this officially makes this new class we're making an extension. And so it's going to need that extend command that we made. And because it's inheriting from it, we're going to want to make sure that this command that we're creating is known as new to hide the one that it's actually inheriting from. We can specify that by saying it's new, and then just overriding the command by defining it again. So public static void extend, and we said that it needs the command database, so command database, database, and then this is going to have all of our logic for adding the commands inside. We'll leave that empty for now. And let's go back and take care of our command manager for a second. Since we've got absolutely nothing here, all we're doing is we're creating a brand new database which has nothing in it. So we need to populate it. We're going to find every type of database extension within the assembly that we're working with, which would be basically our Unity project. So any extension that we make, without even any direct reference, the command manager is going to find them all and is going to call the extend function. And so every one of those extensions that we make, just like we made examples here, it doesn't have anything in it yet, it will, but command manager is going to find this class and it's going to run extend, and then it's going to populate the dictionary, the database, with all of the commands that that example class tells it to give it. Now, that's going to need a couple of namespaces. So I don't need compiler services, really don't. So what we're going to need is two classes here. Let's make sure that we are using system.reflection. That way we can use the assembly functions. And we're also going to want link. And no, I'm not talking about Legend of Zelda. I'm talking about the system.link. So using system.link, because we've got some special querying that we're going to do. So the very first thing that we want is we want a reference to our assembly, and we'll call this assembly, and we'll assign that to our current executing assembly. And this gets us a reference to the assembly where our code is currently executing. So this is going to have all of our database extensions in it. Now to find those extensions, we need to make ourselves a type array, because we don't know every single specific extension that we're going to have. They're all going to be different. But with type being underlined in red here, we don't have the right namespace. And that namespace is simply system. So this type array is going to be called our extension types. And we're going to get that by referencing our assembly, and we're going to get all the types, but limit it to this. Then this is where link comes in. So where we're only going to get the particular types where this logic applies. Inside of here, T is going to represent our type, and we're going to point that to true if our T, or our type, is a subclass, because we don't want the class itself of the database extension. This should just be the base class. So as long as what we are looking at is a subclass of the type of our CMD database extension, then we want to get that and convert it to an array. And so this will effectively get every single database extension that you create in your project. Now let's go through each one of these and call that extend method. So we'll go for each type extension in extension types. We're going to get the method called extend. So we'll say method info, which will hold the information for the extend method. We'll call it extend method, and this will equal our extension dot get method and specify the name of that extend method that we created. And it's got to be named exactly what we defined in database extension. Once we have that, we can go ahead and invoke it. So we can say extend method dot invoke. So invoke will call this method, but we want to make sure that the first parameter is null, because that's the object that it's going to execute the code on. Our code is static, so we can leave that as null. We're not going to execute it on any object. It's going to come from the class itself. And then the data that's going to be passed in to that function is going to be our database, which is that command database, and that is the type that our extend command is looking for. So again, this is going to reach out to all of the code in our assembly. It's going to find every type of our database extension, and it's going to execute the extend method on each of those classes, which being static, they'll go ahead and assign all of their commands that they need to the database, at which point the command manager can access them and execute them at any point in time. Okay, so that's all well and good. We're getting every single extension and we're extending our database, but at the moment, we're extending it by nothing. We know our base class doesn't extend at all because it's the base class, but then the one that inherits from it, we haven't assigned any logic in there. So how do we go about adding commands to our database? First off, our database, where is it? It's right here. The dictionary is private, so we're not exactly going to access that directly. What we're going to do instead is add a command which will add the entry for us. And we're going to call this command, we're going to make it a publicly accessible one. It'll be a void, and we'll just call it add command. Now what add command is going to need is it's going to need a string for the command name, and it's going to need a delegate for the command itself. And inside of here, we only want to add it if it's not already in the database. So if not database.contains key by the command name, then we know it's not in there yet, and we can go ahead and add that to our database. Else, we can log an error. And now this will allow us to use those extend methods to add commands right into our database. So let's go ahead and jump back into our extension to the examples and make a little example that function that we can throw in there. We don't exactly have much capability outside of dialogue, and it wouldn't make any sense to try to make a command for something in the visual novel right now. So another reason for this being examples is we're just going to do something small at the moment. We're going to make a very simple command, which all it's going to do is take a message and log it to the screen. And it's not even going to take any arguments. We're going to start real small right now. All it's going to do is just log a default statement right to our Unity console. So let's start by defining that. And remember, since everything is on the class itself, everything is going to need to be static. But in these commands, you can reference instances of other objects in the scene. And so you can have a mixture of like things that are just tied to the class itself and things that can change inside of the Unity scene at any given time. But make sure that your commands are all static. So here's the first one we're going to do. We're going to make this a private static void, and we're going to call it print default message. No parameters, just in here, and we're going to make a debug.log and give it some kind of message saying printing a default message to console. That's it. Super simple. So in our extend method, here's what we'll do. I'll make a little header and say add command with no parameters. This is an example of how to add a command to our system that takes no parameters. We need to access our database, which is passed in by the command manager, and then we want to access that function we just created, add command. Now this is going to need the name of a command, which I'm going to give it something very simple, print. I just want the command to be called print. But what do I want to do with it? It needs a delegate, and we can assign to that delegate an action. So we'll start by saying a new action, and then inside of this action, I'm going to reference my print default message. And that's it. So this is going to add it straight to our database, and when we call print on our command manager, it's going to attempt to execute whatever command is in here, that command being this, and so it'll execute this logic. So speaking of our command manager, we can't call anything unless we know how to execute it. And all executions are going to come from the command manager since it's the one handling all of this in the scene. Let's make ourselves a new function, public void, and call this execute. And all execute is going to do is it's going to take a string for the command name. We'll get into parameters later, but remember this is just simple right now. So the first thing we need to do is we need to get the action. And again, our database, we might have access to that, but the database of it is hidden. So we need a function to get the command and return it to the command manager. We've got the function to add the command. Now let's make a function to get the command. So this will be public, and we're going to give it the type that it's looking for, which is a delegate. That's the type that's assigned in the database, and that's what the command manager is going to be looking for. And we'll call this get command. And we're going to be looking for a command by a particular name. So what are we doing here? Similarly to how we were checking if our database contained the key, we're going to be basically doing the same thing here. We'll go ahead and copy this, and we'll paste it in here because we want to perform the same check. And if we do not contain the key, we'll just flip this. So we want to take the error message, and we want to pop that in here, and we want to return null, because it does not have a command if we don't have the key. So I'll change this message up a little bit. There we go. So if it does not have the command that we're looking for, return a message and return null. Otherwise, if we do, then, well, we don't need this else here, because if we've made it this far, then we know that we have it. And we can just return the database specifying the command name. And when we do it this way, it's going to give us back that delegate. It's going to give us the value of whatever key that we're specifying here. So back in here, we need to get our command for whatever we're trying to execute. So we'll say delegate command equals database.get command and pass in our command name. And to execute it, we can simply say command dot, and we can call a function dynamic invoke. And it takes nothing in there, so that's it. If we have that command, it's going to return it. So let's do a quick check. If command is not equal to null, as long as we have the command, we'll try to execute it. I'm going to go into Unity and back into our testing scripts. I'll make a new one, and this will be for command testing. Now our command manager is an object that's supposed to be in the scene. It'll have its own instance, so we need to add a new one under managers here and call this our command manager. And we'll add the command manager script. There we go. And so for testing, I'm gonna disable that one and just add a command testing script to it. And let's open that up. Inside of here, we're just gonna call one little thing, and that will be our command manager dot instance dot execute, and I'm going to call that print command. I get a null reference error when I try to run this in Unity, and I look at my managers, and my command manager's not there anymore, so I already know exactly what I did. I did this stinking backwards. Remove that. It's checking if it's null, we're doing all this. If it's not null, destroy it. Man, I do that a lot. But once I correct that ID10T error, now we have our message printing to the console. So, printing a default message to console. That is without any instance of our database extension in the scene. It grabbed it straight from the assembly, it grabbed the logic, and now we're able to call it. That is the start to our powerful command system. And so I am going to stop this here. I see that we're already at 53 minutes, or at least it's 53 minutes at the time of my recording. That's before editing. So what I'm going to do is just stop here. We've done enough. We've covered a lot. And the next episode, I'm going to make it where we extend this system, so that way we can accommodate for the other types of commands that we can use. Right now, all we have is a command that takes in 0 parameters, but we want to take in parameters to our other commands, and we may also want to run long-running processes. Those would be coroutines. So we'll want our command system to be able to handle all of that, and we'll take care of that in the next video. So good job you followed this far, and I'll see you in the next one.